Okay, 2 o'clock on the dot. Let's do this. Thanks for coming. Thanks for joining us today. I will tell you, just start off, that I am presenting in a different venue today. I'm at a hotel in Toronto. I'm here for a conference. So if we do have any internet issues, I will let you know. But I do want to point out that Amanda, who's on the participant list, works at Luna Geospatial, and if there's any issues seeing me, if for some reason I cut out and I don't realize it and I just keep on talking about PostGIS, message her, let her know, send her a private message on the chat. But I don't anticipate any issues. I have pretty rock solid internet right now, but there are some sort of port issues sometimes that I have with QGIS, so we'll sort of cross that bridge when we get there. But welcome all to Spatial SQL Isn't Scary. I was very excited to put this webinar together. This is a subject that I really like talking about. I enjoy talking about spatial databases. It's something I do every day and something I work with all the time and something that I'm always learning about. So I thought I would put together a webinar, and this is kind of a webinar that I put together thinking if I was just getting into this again, or if I was getting into this for the first time, what would I want to learn about just to get started? This is by no means an introductory course, but I'll sort of run through a couple of things and then we'll dive into the magic that's scheduled. So the first thing, just a little bit about me. I'm the founder and CEO of Luna Geospatial. My name is Cliff Patterson. And I've been working with open source GIS since about 2007. I work a lot with, I consider myself an expert in QGIS, PostGIS, and GeoServer, among other activity and other software. I do a lot with GDAL as well. We do a lot of web map development at Luna Geospatial, so we do quite a bit of that sort of software development. My PhD, I did in New Zealand at the National School of Surveying at the University of Otago in Dunedin. I looked at tropical deforestation, agricultural intensification in northern Belize. It was at that time that I really got exposed to remote sensing using Landsat, and now I use a lot more Sentinel whenever possible, and other sensors that are available to conduct things like land cover change research. I've worked in a number of different sectors. So I've worked in conservation, government, archaeology, software development is what I'm doing most now, and as well as independent consulting, which I've been doing for a number of years. So what we do at Luna, we do consulting and training. This is one of the #1 things that we do. Anything to do with open source GIS, we're on top of it. We do remote sensing as well. We conduct training. And webinars like the one you're in right now, as well as providing commercial support for open source GIS software. We also do software development. We develop web GIS dashboards, data portals, mobile applications, anything really that's database driven, especially if it has any type of spatial component. We are definitely all over that. The last thing we also offer are our GIS servers. These are fully managed GIS servers that leverage tons of open source software, including Postgres, PostGIS, GeoServer, among other pieces of software. And these are completely managed, completely backed up by our team. Okay, so today, enough about that. Today, what we're going to go through. We're going to talk about what is the spatial database very briefly. I'm not giving a lot of overview for this stuff. We are just really going to want to jump into it, and I want to show you some spatial SQL. This is kind of a hand-holding session, and I designed it as such. I'll talk briefly about QGIS integration with PostGIS. I will talk a little bit, then I'll go into the SQL stuff, and we're just going to look at some basic SQL statements, queries that we can run, and then we're going to look at some basic spatial functions that we can run thanks to PostGIS. We're going to look at measurement functions, geometry functions, spatial joins, proximity analysis, output functions, and trigger functions. And the whole goal of this, I will say, is to show you that spatial SQL is really not scary. There's a lot to learn. It feels like a lot, especially if SQL is something you haven't used in the past. Maybe you have used a little SQL in the past, but you've never done spatial stuff. Well, this is kind of just the goal here is to really give you a taste. And so the target audience is really anyone interested in spatial SQL. No prior experience required in any of this, right? So feel free to just sit back, watch, get an idea of how this works so that you're better prepared to actually dive into using this technology if you want. I will say that there is a little bit out of scope here. So this is not a full introduction to PostGIS or Spatial SQL. This is not going to teach you how to install it, get it running on your system, set up a demo sort of server that you can run Postgres on. We're not doing that. We're not going to talk about setup or installation or anything. I have a database set up. We're just going to run queries against it. And I'm going to show you how that works within a QGIS environment. So with that said, I'm just going to turn off my camera just to free up some of the real estate on my screen here. And we're going to dive into this presentation. All right, so what is a spatial database? Big question. So Postgres is a relational database management system. And PostGIS is a spatial extension that plugs into Postgres, and combined, when combined, then they are essentially a spatial database. There's also others. There's Oracle, there's DB2, there's Microsoft SQL Server. But in my humble opinion, the combination of Postgres and PostGIS is probably one of the most powerful spatial databases available today. So PostGIS adds spatial data types and over 400 functions that can be used on these spatial data types. It also provides the ability to store, manage, and analyze geographic data within the database using structured query language, SQL, which is what we're going to be looking at today. So what about integration within QGIS? One of the things that's really nice is that there are many ways in which PostGIS is integrated within QGIS. It was actually integrated really from the beginning of QGIS's development 20 years ago. So the database manager is the first way. One of the most amazing pieces of software within QGIS for me is using the database manager. You can run queries, you can import layers into the database, you can export from the database, you can modify existing tables, you can truncate an entire table if you want, you can delete certain rows. You can really do anything you need to the database. But one of the neat things you can do is you can also run SQL queries against your database. So good stuff. And this is obviously what we're going to be doing today. But there's also some other features. I love the combination of PostGIS and QGIS. I have a number of clients who obviously use this. So you can save symbology. You can do things like saving default symbology within the PostGIS Postgres database. And you can also do things like save projects. So your QGIS project can be saved directly into the database. And you'll see that when I dive in and start showing you how this works. So let's talk about some basic SQL queries. Now, I realize that many of you might have never even touched SQL. Maybe you have touched SQL and you don't even know it. If you've used the expression builder within QGIS, chances are you've used a number of the operators that you would use within a SQL environment. So a very simple one is, show me all the rows in the demo table. So that's select star meaning everything. It's our wild card from, and this is the thing, when we're looking at a database, there's two parts to it. There's the schema. So think of a schema for now as just like a little folder. It's like a file folder where some of our tables might exist. And then we need to call the table and we need to put a period in between and close it off with the semicolon. All right, so when we do this quite easily, now we're in QGIS and we can open up the database manager. We can open up our training database. And right here, we're looking at the different schemas within the database. And I've created one for this webinar called Spatial _SQL _webinar. And I have a number of tables within that. And I can run these queries that I've written against it. So this basic SQL query, select star from some table, execute, and we get a list of names and a list of ages associated with those names. Okay, so that's pretty easy. Select star, show me everything. All right, so now what about where? What if we only show me all individuals who are over 40 years of age? So we can come back to this again and we can have the basic where. So again, we're doing select star from Spatial SQL webinar. We always have to state the schema in which the table lives, and then we put the table name right here, and then we have a where clause. And we can do a lot with a where clause, and it's probably the most basic thing we can do, where we take a value that's set as an integer within the database, and we can use the greater than operator on it. So age is greater than 40. Boom, we end up with a nice table. When we run it, oh, we get an error. Isn't that nice? No, we had something highlighted. All right. So when we run it, we get the individuals whose age is higher than 40. Easy, right? Nothing scary at this point. Let's keep on going. So what if we want to update? What if we want to say, you know, there's a row that has the wrong value? Let me go back to this, and I'm going to show you our original query that we just ran. When we execute it, we have a number of different individuals here. And we have an ID value. So this is our primary key within the table. And our ID value for Bob is 1. And Bob is set to 21, but Bob's not 21, and that's our problem. We want to actually set Bob's age to 50. So to do that, we use update. We use update, and again, we're stating the same table, Spatial SQL webinar.demo table, and we're going to use the set clause. We're going to set the age equals 50. Now, we don't want to do that to everyone. If we stopped here, if we just ran the update and the set, we would change everybody's age to 50, and we'd screw up our whole database, and somebody would be very, very mad at us. So we add the where clause. We say only set it to 50 where the ID equals 1. So now we're going to go here. I have all these written out for us and saved to speed this up. So now I'm going to run this. So when I run this, there's no output for an update query, but I can come back now to our original query, execute it, and see that Bob is now set to 50. Okay. I will say too, as we're going through this, if you have any questions, feel free to drop them in the chat. I'm working on a single monitor. Usually I have duals and I can sort of see what's going on. But if you drop them in the chat, I will address those during the Q&A period when we get to the end of this. All right, so what about insert? We want to add Peter, and Peter is 47. So again, the basic SQL query is using the insert into, and what are we inserting into? We're inserting this into this schema and into this table that lives within the table. And then we're going to identify the fields where we want to actually enter the values. We want to enter them into the name field and the age field. And the values we want to enter are Peter, within quotes, and 47. You get used to some of the syntax in this as you're using it. You know, you'll get an error. If I didn't put these single quotes around Peter, I would get some sort of error. So let's go into the insert now. So our basic insert is here. We can execute it. There's nothing that's going to pop out because it's not a select query. So there's nothing that's actually going to show. So let's run our select query again. And we're going to see now that there is a 6th row. ID equals 6, and this is Peter. Okay, so we're doing great here. Now, you're probably wondering, this should be 5. Well, I've done some adding and deleting over time. So what happens is there's something called the sequence on this ID field. So even if you delete number 5 in the ID and then add another one, the next one won't be 5, the next one will be 6 because 5 has been dealt with already. So you can't recreate it. Long story. All right. So now let's go to delete. Now we've decided we want to delete one that has the ID value of 5. We're going to have to change that for this demo because now I told you already 5 is gone. The ID value for Peter is actually 6. So if we're going to go into the basic delete, now I want to change this to being 6. So I run this, I execute this, I come back, I go to my basic one, which is just select star to see the whole table. And we see now that Peter is no longer in the table. All right, so we've deleted, we've updated, we've inserted, we've selected, we've used a where clause. So what else do we want to do? What if we want to create a table? What if we want to replicate that table that we just created? Well, we can do that easily. And most of the time when I'm designing a database, I'm doing it right here. I'm using, I'm using probably another program that I used for writing SQL, but I will actually write it out, the whole database as I'm developing. So I'm developing trigger functions and all this stuff. I will write it all out by hand like this. So we're going to create a table. So when we're creating a table, we're using the create table command. And where do we want to create it? Well, we want to create it in the Spatial SQL webinar schema, and we want to call the table demo_table2. It has an ID field, it has a name, it has an age. And the thing is, when you're creating a table, is you have to have the name of the field, and then a space, and then the data type associated with it. This is going to come into play in a few minutes when we start talking a little bit more about the spatial data types. And so when I run this, it executes, there's nothing, it says it's successful. But if I come over here now and refresh this schema, I can see now that I have a demo table 2. And if I go to the info tab, I can see indeed it has an ID field, it has a name field, it has an age field. Now, if I go to the table, there's nothing in it because I haven't inserted anything in it, but I have created the table. So I could go through and start adding data to it. Okay, so we've done sort of all the basics. We get a sort of idea of SQL. Now let's have a little more fun. Let's do spatial stuff. All right, so basic spatial functions. All right, so let's just talk about something that we all do all the time. If you're doing any GIS, you're going to be doing a buffer. So you can do a buffer within the database as well. One of the things I love most about using a spatial database is that it cuts down on clutter. So if you're in a GIS environment that uses files, chances are you have a file system that's full of buffered and clipped and cut up in different ways, shape files that exist, and with names like version 1, version 2, version 2 underscore final 1, final 2, final 3, final 4. No, this one, final. No, okay, this one's done. And it just ends up being a clutter of garbage. So one of the things that's really nice about using QGIS with PostGIS is that you can run these queries, load them into a project, and view them. So I'll show you this first. So let's go with some basic functions. Let's go to our basic buffer here. Now we execute this. I'm going to show you how this works. So we're doing a buffer. Now, I was talking to you about the spatial data types. I can't go into this and give you a full intro, but one of the things that adding PostGIS to Postgres does is it creates a variety of different spatial data types. So just like we might store an integer, we might store a text in a text field, and we might store something with a decimal and a numeric or a decimal field. Now we have this new data type, and we have a bunch of different new data types. So point line polygon, of course, then we have all our multis, and we have 3Ds and things like this. But all that geospatial data can now live within the database. Kind of cool. So when we're doing it is that where we store our geometry is a field that's typically called geom. You can really call it anything you want, but for the most part, the sort of industry standard is just save geometries within a geom field. Now there's geographies as well, but that's a whole other topic that will be covered in an upcoming training session. But for now, let's just think about geometries, and we're going to store them in this geom field. Okay, so what are we doing? We're doing select. We know select. We went through this. So we did select. We're going to select the ID value, and then we're going to use a function. So a function is this st buffer, and then in parentheses we have to pass two parameters. The first parameter is the geometry. So we're taking the geometry of this Windsor Community Centers. Now I will say the data we're using for this comes from Windsor, Ontario. They have a really great open data portal. So if you just Google, Windsor, Ontario, open data or GIS data, you'll find it. You can download their parcel data, the same one that I'm using now in these community centers, and mess around with this if you want. And then we're going to pass the word as. So basically we're saying if we want to run this function, but we want to call the column geom. And I do that for a reason, because I want to actually load it within QGIS. From, where am I getting it from? I'm getting it from this schema, and the table name is Windsor Community Centers. So let's look at Windsor Community Centers just for a sec. So Windsor Community Centers has a geometry field. It's a geometry, and it is just increase the size so everybody can see this. It's a geometry. It's point Z, so it does have the 3D element to it, and it is in EPSG 26917, which is NAD 83 UTM 17 North. Okay. So this is great. We're good to go. We can run this query. We have run it, but one of the neat things about how QGIS is integrated within, PostGIS is integrated into QGIS is that we can load as a new layer. So for any of you who frequently use other GIS platforms, sometimes you can run something and load as a query layer. Sometimes that's just the extent of what you can do with a spatial database. With this, you can do it as well. So you run this query and you're going to press load. Now, when you press load, it reruns that same query. But now what we find is our query layer, and you see it's named query layer on the map. I'm just gonna put it below the community centers. Now we have a 500-meter buffer that's loaded, and we can zoom in and we can do things to it. Now, this works really well. Okay, so when we've been able to run this query and load this in, from here you can do a lot of different things. You could save it. So if you wanted to save it as like a shapefile or something like that, you could, or into a geo package. And I'll show you a bit of how you can actually turn these queries into new tables. But that's one of the most basic things we can do. We run a buffer and we can display it on a map. Okay. So what if we want to ask more questions, like if we want to do intersect analysis? So which parcels intersect the community centers? All right, so we have a parcel data set here with like address and everything on it, and we want to know which one of these actually intersect with the community centers. So next query, buffer intersects. All right, so select a.star. Now, what is this a.star now? A is referring to, if we have two tables within our query, we're going to give them an alias. For this one here, let me just bring this down here, it'll be easier to see. For this one, we're giving the Spatial SQL webinar.windsor parcels. We're just going to call it A. A lot easier, because then when we call it in other places, we're just going to be calling it by A. And then we have another table, which is the Windsor Community Centers, which is also in the Spatial SQL webinar schema, and we're just going to call that B. So super easy. Now we just want to return everything from A, which is the parcel data set. So in our where clause, this is where our ST intersects comes. And this is our spatial function. Our spatial function takes two parameters, two geometries. In this case. So we're taking the A geom, which is the parcel data set, and we're also taking the ST buffer of the community center. So we're taking that 500-meter buffer, and then we're going to intersect that 500-meter buffer with the parcels. So when we execute this, it'll run for a few seconds. We're getting 9,567 rows back in about 1.18 seconds. And we could also load this. So if we did want to load this into the database, it will run the query one more time. And then if we come into QGIS, we're loading now a new layer that just has the parcels that are within 500 meters. I'll just turn this off. 500 meters. It's hard to see if we zoom out, just because of the symbology, but all the parcels that are within 500 meters of these community centers. So pretty cool stuff. Okay, so that's how we do a very simple sort of buffer intersect. I think we all do this quite a bit, especially if you work in the GIS field. Okay, so we've done this already. So the buffer intersects, which is great. And that was the key part, is with that the ST intersect shows up in the where clause. All right, what about measurement? One of the things I always joke about is that anybody who's gone to school for GIS, they can do all these things, they can create these elaborate models, but sometimes the majority of your work is spent finding coordinates and telling somebody that a road is 213 meters long. And that's what we do quite a bit. So what about the area? So this is a fun query because it mixes a few of the different things that we do, that we've talked about up to now. So for this, we're going to say, what is it we're asking? What is the area of all parcels zoned for agriculture? So in this data set that I've been showing you, let me turn this off now. When we're looking at the parcels, there is a zoning field right here. And each one of these values refers to some sort of zone within the municipality. Okay, so we're going to say, we're going to select star. So we want to get everything from what? From this parcel data set that we're using. Oops, sorry. From this parcel data set that we're using. And we're going to use a function called st area, which computes the area in meters in this case, especially because we're using UTM. And it will add that value to a new sort of column that's going to be called area underscore SQM for square meters. But we don't just want to select every single parcel. We only want to select the ones that are zoned with that start with A. So there's a bunch of different agricultural zones like A 1.5, A 1.8, things like this. So we're using this wildcard, and in SQL we can do this. We can use like, so zoning like, and then our query will be A with the wildcard. So A, anything after that will work. Okay, so let's try this. All right, so here's our ST area. Now, this will get the area of all parcels zoned for agriculture. So when we run this now, we're getting a list of 192 rows. You can see that here. And now we have the area. So we've automatically computed the area. And that ran in 0.103 seconds on a parcel data set. Now, the parcel data set is about 77,000 rows. And I'm using this on a cloud-based server too. So this is actually pretty zippy. All right, so we've done this now for the area. We're able to calculate at least the area of all of the agricultural zones. So now let's ask another question. So what is the total area of all parcels zoned for agriculture? So now we're going to use something in Postgres called an aggregate function, and we want to sum. So we don't just want to get everything that is zoned for agriculture. We want to sum the entire thing. So I can say, so when somebody walks in the office says, Patterson, I want to know how much of the city is used for agriculture. Now I can just come in and say, okay, I can run this query and I can execute it. Oh, sorry, not that one. Sorry, too small. And one of the things that's nice here, if you're running multiple queries, is that you can just highlight what you want to execute, and you can run it. So it is this one right here that I want to run. So now I execute this and I get the sum area for all agricultural areas, and I have a value now that I can work with. So the next thing we want to do is so we want to actually clean this up a bit. So one of the things that we want to do is we want to bring in a function from Postgres, which is the round function. So don't worry too much about the syntax of it. Just know that this is something that you have to do occasionally. So the round function will only take a field called numeric, whereas when we're using something with the ST area, this will produce it into the data type called a decimal. So this is a problem because round function won't work with a decimal. So what we have to do is we have to do this little fancy thing with 2 double colons, and we're going to cast it. So we're going to sort of convert it into a numeric field. So we have this round function, and then we have the exact same query that we ran before, or the select statement that we ran before with the sum. And then we're going to have that, call that the sum area square meters, but we're going to clean it up. So we're only going to have 2 decimal places because the round function will take a value and then comma, and then it will take the number of decimal places that you want in this. So if I come into here and I run this again, now the value that we produce has 2 decimal places. Now we can do the exact same thing with that first statement that we did as well, that returned 192 rows, but now it's a little cleaner, right? So we don't have 8 decimal places. So unless you're, measuring the size of an atom, you can probably, and the unit of measure is meters, you can probably reduce it to 2 decimal places, and you'll be happy with that. Okay, let's keep on going. All right, so I showed you this. Ooh, length. All right, so one of the questions you might be asked sometimes, especially if you work in the municipal sector, is, sort of how many segments are there for a certain street? So in this example, there's a street called Richmond Street, and how many segments are there for Richmond Street, and what is the total, minimum, and maximum length of these segments? So now we're using a bunch of different aggregate functions. We're using sum, we're counting the number of segments, we're using round here, but we're using round on the max and the min for all the different segments. And we have a where clause where we have a street name, which is st name. I like, and this is another one that we haven't talked about yet. I like is case insensitive. So I can write Richmond in lowercase, and then I put that wildcard after, because I don't know, maybe I don't remember, is it a street or Richmond Drive or Richmond Avenue? Doesn't matter. I'll put the wildcard there. All right, so if we come down and do the length. So right now, we're going to run this, and now we've just produced some stats, right? So we have the sum of the length, And again, we probably should have wrapped that around a round function to clean this up again, because we have, I think, more decimal places than we do actual values on the left side. And then we have the segment count, there are 17, and then we have the maximum is 247 meters and the minimum is 50 meters. And we could add a mean if we wanted to calculate that, and that could just be added to the select clause here. But you can see we're just using spatial functions as well as using the functions that are within Postgres, so we can combine these all together. Okay, so what about perimeter? So what is the perimeter of all parcels zoned for agriculture? And again, we can use the same thing. Note we're using round again, so we only have 2 decimal places, but we're using ST perimeter on the geom. We're casting again to numeric, and we're saying we want 2 decimal places. And we're going to call the resulting column perimeter underscore meters from that same parcel table where the zoning is like this. And then we're going to order by. So I'm actually going to order the results by that perimeter. Okay, actually I could have written that one differently, but it's okay. Some people who know this stuff might be saying, hey, you can do that easier. There's always different ways of doing things. Okay, so right now we see that we have this perimeter field, and we have all of our values here from lowest to highest. And we can, of course, do an invert if you want, and you could have highest to lowest, but we'll see that in a sec. All right, let's talk about geometry functions. All right, so again, this is another one of those common tasks that somebody's going to come up and say, hey, can you tell us the coordinates at this location? You give them the UTM. They're like, no, we want Latin long. And you think to yourself, I did 4 years of school, so I can give you Latin long. Yes, you did. But PostGIS is going to make it a lot easier for you. Okay, so before we dive into that, sorry, 1 second. I don't like this here. Let's take this away. This doesn't have to be here. So first thing we're going to do is we're going to talk about ST transform. So transform is just going to sort of project your geometry to another coordinate reference system. So in this case, I uploaded the arenas, and the arenas were uploaded in WGS 84, so EPSG 4326. But we're working in 26917, so UTM zone 17 north. Problem. Okay, so now when we're using a lot of these tools within QGIS, it will just project on the fly, and you can sort of mix geometries of different coordinate reference systems, and QGIS will know enough to fix that. Well, when you're using SQL, you have to be very explicit about how you do this. So in this example, we're going to transform the geometries using ST transform. So we're going to select everything from A, which is the parcels, and we're going to do an ST intersect. So we're just doing an intersects on the arenas that intersect the parcels. So we only want to return the parcels that intersect with our arenas here. Okay, so now if I was to run this, so 1 second, number 13. So if I was to run this, this produces no result. Now, the main reason here is because I'm taking the A geometry and B geometry, which is the parcels and the arenas respectively. And when I do the ST intersects on them, nothing's showing up because you're comparing a lat long coordinate to a UTM coordinate. So of course they're in completely different locations, and nothing will work. But as the comment there indicates, this does work. And we have 4 arenas. And now we're able to run that ST intersects. And the main reason is that if you look down here, is that when we're using the ST intersects, we're taking the geometry of parcels. And again, a reminder, that's in UTM. And then we're using ST transform on the arena parcels. So we're wrapping it in a function within another function. You're going to find that the more you use PostGIS, you're going to be nesting a bunch of different functions within individual functions. And this is just the way it works. And you're going to transform that to 26917, and then you get the result you're looking for. Okay, we're feeling happy. You're going to use ST transform all the time if you use this. Okay, next. Okay. Next is STX and STY, and this is where I come back to people just want their coordinates. And sometimes people want their coordinates in a bunch of different formats. So they might want the UTM coordinates, but they might also want the the coordinates in latitude and longitude. So here we're going to produce the northing and eastings, and we're going to produce the longitude and latitudes. And I'll show you how to do this. So we're going to be using a round function, wrapping around, putting an appropriate number of decimals. For UTM, we're going to use 2 decimal places. Remember, the arenas that we're working on, the Windsor arenas, is already in WGS 84. So we don't have to transform to get the latitude and longitude. They're already in that. But those don't exist in the table itself. So if we do look at Windsor arenas and look at the tables, like these aren't individual fields in here. They live within this geometry field. So if we come back, we want to have a table that basically has all the coordinates for all of them. Okay, so let's go to this, number 14, STX and Y. This is our first one that I just want to show you. So we're just getting the longitude, we're getting the latitude. Okay, great. Now, but I want to show you that larger example that should get you both. So when I run this, I'm getting both the easting, the northing, longitude, latitude. So we're good to go. So this happens a lot. Again, this is probably like the most common request you might get in a GIS department, is just get me the coordinates for something. But we can do a lot more than that. So what if we want to get the centroid? So what if we're working with polygons and we want to say, okay, I want to get the coordinates for that point. Fortunately, PostGIS has a wonderful function called centroid, where the only parameter it takes is the geometry. We then will call it. Now notice here, I didn't put as is kind of optional in the select right here when we're creating aliases for fields. So I'm just going to do this, and this picture, there's a word as here, as geom. From the schema, and again, we're using the parcels. And right now I'm just going to be doing it for a certain one. So I'm going to say just this one. I've already figured out that it's the ID value is 16257, and I put that in there. So if I come to the next one, we're going to be using centroid. And if I run this, I can get that actual point. Now I can't load that onto the map right now because I have multiple queries in here, but I will show you this one. And so we can run centroid with a bunch of other functions as well too. I want to show you how we can produce the easting and the northing with that same function. So again, look at all the nested functions we're using right now. So we're using round because we only want to have 2 decimal places for the easting. We're using STX, which we just learned about, to get the X coordinate. And then we're using centroid to get what do we want the X of? If you run the X on a polygon, it's not really like which X do you want? Which vertice do you want here? So now we're saying no, we want the coordinates for the centroid of that polygon, and we're going to call it easting. And then same for the northing. Okay, so when we run this, we get these values. One of the things that's nice now, if I just quickly delete that and I only have one query in here, I can run this and I can load this onto the map. Now, if I come into QGIS, I have this new layer and I can zoom in, and we're zoomed into that coordinate. Oops, sorry, wrong one. Oh yeah, sorry, it is right here, just very small. Okay, so now we have that point, and if we identify that point, we can see that we have those easting and northing. Now we can save this as a new layer if we want, or if somebody just wanted those coordinates, we can just pass those along to them and our job is done. The nice thing, we haven't created any additional data. We've just run a query against a database. All right, let's go to the next one. So we've done centroid, we've used STX, STY, and so on. What's next? All right, so we're going to talk about start points and end points. So we're going to get the start and end points of a line string. So this just gives you an idea. There's 2 functions that you can use called start point and end point. So start point is going to give you the coordinates for the start point of that line string. Now you can't do this on a multi-line string. You can, but not as easily. You actually have to split up those multi-line strings if you want to use this function. But right now I have a layer that's set up as just a simple line string, so we're able to do this. So what we want to do is we want to select the start point, and we're going to store it within a field called geometry from the demo line string layer that I have that's sitting within this Spatial SQL webinar schema. And then we're going to use union. Union is basically going to merge these 2 queries together into a single one. So let me show you how this works. Okay, so now we have this query that I just showed you, and we are going to execute it, and we end up with two geometries. So let's load that into QGIS. So if we load this within QGIS so we can see it, now we see, here's the line string. We see that we now have a point at the start and the end of this line string. So this can be really handy where we want to create points along a certain line, because there's other functions you can use that can create points from the start to the end. So if you wanted to then create those points, then maybe do some sort of sample on some data underneath at each one of those different locations, you can do that quite easily within PostGIS. Okay, how are we doing for time here? Looking good. Spatial joins, let's do this quickly. So you can join, right now we're gonna join the community centers and the parcels if they intersect. So a join, if anybody has done anything within databases, you know that a join will have to be on some sort of common field. But with the spatial extension, we can make joins based on spatial relationships. Kind of cool. So we've already talked about st-intersects, the function that looks for an intersection between two geometries. So let's do this now. So in our select, notice we have our A's and our B's. What's our A? So our A here as A, that's our community centers, and our B is the parcels, but we're using something called a left join on that. So that's one of the first things I'll talk about, is that the left join basically takes everything on the left side. And if it doesn't join with something on the right side, then the rest of the right is not shown on the result. So since we have 16 community centers, the result for this query should be 16, assuming that there is a parcel in every location where there's a community center, which there should be. Now, the only field that I want to take once I create this join, I'm creating the join on a spatial relationship where the two geometries intersect. But the only values I want to take everything from A, which is the community centers, and the only thing I really want to get from parcels is the roll number, which is in a field called the roll fix. So I'm going to be bringing that over. So in the end, what we're going to end up with a table that has the community centers with a new field called the roll fix. So this spatial join, exact same one that we just looked at, we run it and we have exactly that. We end up with all the fields from the original community centers, but we've created a join now based on a spatial relationship to the parcel data set, and we've pulled out a value. Now we can create new data with this. Which is kind of neat. And we can run different types of queries on this. Okay, perfect. Let's dive through. I want to make sure I get to some of the cool stuff coming out, like proximity analysis. All right, so now we're getting into bigger, fatter queries. All right, so we can ask questions like, how far is each parcel from a community center? Now, how far? You're thinking, well, we should do network analysis. Yes, that's possible within PostGIS, but we're just going to keep it simple, and we're going to do this as the crow flies, as they say. All right, so for this query, we're going to be using something different here. We're using select distinct on, and don't let that bog you down just yet. That's basically saying that for every single ID in the A table, which is the Windsor parcels, I want you to be, those are distinct. We don't want to produce multiple results for them. We just want to produce one result per parcel data set. So this is a bigger one. We're running it on 77,000 parcels, and we're going to be doing the same sort of left join that we did last time. But we're going to be producing the distance. So we're using st-distance, which takes two parameters, two different geometries, the A geometry and the B geometry. And we're going to be adding that to a new field called distance_meters. We're going to join the two tables with a left join on a new function called std_within. And this will look for a relationship, a spatial relationship within a certain distance. So in this case, I'm looking at it at a 10-kilometer distance around. So if it's beyond that point, it won't join those two layers. And we're going to order by the ID value and the distance. And in order to use this distinct on, and in order to do this function, these values that we're using have to appear in the order by statement. So this is a bigger one. Let's do this. Okay, so we've loaded up this query. We're going to run this. Oops, that went a lot faster than I thought it would. Sorry, where were we? Distance. Boom. All right, this one. Now, this is going to take about 15 seconds to run, which feels long, especially when you're in a webinar and you're just watching and you're hoping nothing crashes, because live demos are always very stressful when you run big things like this. And I've noticed that when I run this one in particular, sometimes bad things happen. Look at that, it worked. So this ran in 16.6 seconds on 77,000 rows. And if we move to the right here, we can see that we've created the distance field. Okay, that's really cool. Now I could press load layer to QGIS and it would work, but because it's kind of slow, whenever you pan and move, it sort of runs the query again. And this makes things very slow to work when you're running with such a large query layer. So one of the things that we're going to do is, instead of having just this is the result, right, that we want. And I'm going to show you this in a sec. But we're going to actually create a new table. So this is where I was telling you that we could take a spatial function and we can create new data out of it. So we're going to create table, and we're going to call the table Windsor parcels with community centers as, and then we're going to put that whole query that we just had right here. So when we run that, and I have it already prepared, we create a new table within the database, which is right here, Windsor parcels with community centers. And I've already done it. And I've already applied some symbology to it, and I can turn this on. And now we can see visually this relationship between community centers. And here we have one right here. We have a community center, and we know that the distance based on the symbology that we applied, and we can make this look a lot nicer than it is right now. But this is essentially the result of a fairly straightforward spatial SQL query. We've created a new data set out of it, and then we can use this. Now, there's a bunch of other things that you can do with this. You can update an existing table. So if you just want to say, you know what, I want to update this existing table and I want to add a new field, you can also do that as well. You don't necessarily have to create a new table. You could just add a new column within an existing table based on a spatial relationship. So a lot we can do with this. But one of the things is, once we have this data set, we can ask a bunch of new and exciting questions with the proximity analysis. So neat thing here is ST distance 2. So this would ask, let me just run this. Oops. Oh, sorry, I don't want this one. That already exists. Okay, so a bunch of different questions that we can ask. So how many residential parcels are there within 500 meters of the Willisted Heritage Complex? So now with this, let's just focus on the where clause here, where the center is this Willisted Heritage complex, and the distance is less than 500 meters, and the zoning is RD, which is residential. And we can run this and we can get the value, and that's 1,013. Very quick. And then we can also ask questions like, which community center served the highest number of residential parcels within a 2-kilometer radius. And what's fun about this is that we're going to do the same type of thing. We're doing zoning, residential, and distances less than 2,000 meters. But what's neat is that we're going to now arrange this in descending order. So let me run this and you'll see the results. So we can execute this. And this is the number of residential parcels that are served by the individual community centers. So we can see that we go from the top, which is 8,755, down to the bottom, which is 196 residential partners. So there's quite a big divide in that community between how many residential parcels are served by these community centers, at least as the proverbial crow flies. Done that one already. I'm going to run through this quickly because I just want to show you something really cool before I let you go. Okay, so spatial output function is another big one. So we can output as well-known text, and we can output as enhanced well-known text, which is a sort of a PostGIS version of well-known text. So I'll show you this also in the trigger function that I want to show you when I'm done, is that basically we're running a select and we're using this function as text, which produces the well-known text on the geometry, and it will produce it in a table. which is nice. We can also do this. Everybody's familiar with KMLs. If you want to turn a certain geometry into a KML, you can also run that same output function, and it will create a field called KML from this query, and it will give you the KML XML code. Okay, next, if you want the GeoJSON, if you're going to be using some sort of web application, you want to have that and you want to use it in JavaScript, you can also produce GeoJSON in this sense, and this PostGIS will produce that. Okay, so these are outputs. I want to talk about this because I want to give you a little demo on how this works. So a trigger function is nice because whenever you update something, whenever you change something, there's a bunch of different parameters you can set. It will do something. It will run a certain function that you've written, and it will make update a certain number of fields. I love doing this because if I know what I'm doing, if I have a set detailed analysis that I want to do, I can run it on each feature that I create. So if I'm digitizing something, I remember doing this when I used to fly UAVs. And at the time, we had to know the distance to the nearest road. We even had to have the coordinates in DMS. So degrees, minutes, seconds. So we had to be able to report those. So if I was to report something in latitude, longitude, and decimal, that was not acceptable. I had to actually report it in DMS. So to solve that problem, I used a trigger function, and automatically when I drew a polygon on a map to say this is where I'm going to fly the UAV, it would populate a whole bunch of fields. So the first step to do this is you got to create a new table. So I'm going to create a table. It's going to be a polygon. We see the geometry here is set to being a polygon. And again, it's in 26917, which is the UTM zone that I'm in here in Ontario, Canada. And then the second, it says step 3. All right, it's step 2. So step 2 here is actually creating the spatial function. So we have the tutorial trigger function that we're creating. And don't worry about all of this. There's a bunch of blogs and things like this. I wrote one years ago, and I'm going to write a new updated version on the Luna Geospatial website at some point. So we can create this function. And note that it's going to have a whole bunch of these spatial queries. So the new value is this new geometry that we're creating. So in this scenario, I'm just creating a new polygon on the map. And I'm going to be using a bunch of spatial functions on those. And all of these seem quite familiar to you at this point. We're using the round function. We're using STY to get the Y coordinates. We're using the ST centroid on the new geometry that we're creating. We're casting to numeric, and we're having 2 decimal places. I believe somebody has their mic on right now. Could everybody please just make sure you're on mute? The actual third step here is the trigger. So we create the trigger. And we're going to be calling this tutorial trigger in this sense. And this is what's actually when it's going to actually trigger. So it's going to trigger whenever we insert or update any of these polygons. So the whole function looks like this. So I create a whole bunch. I'm intersecting with the ward. I'm finding the nearest road name. I'm finding the distance to the nearest road. I'm finding the nearest hospital and the distance to the nearest hospital. And the scenarios here is that we're planning a new park, and we just want to produce a lot of data whenever we put a polygon on a potential location where we could put this park. So this is where things have been crashing out for me. I think it's just making a request over to the there's some sort of port issue using the internet that I'm using right now, but this should work okay. So this is my proposed park area. So if I turn this on, I run this, we'll know pretty quick if the internet is not happy with this. It opens up this table. So if you saw from my QGIS forms webinar that I did, I created this fancy form that has all of this, but there's no values in here. There's nothing. So I'm just going to press OK on this, and I'm going to press save and turn off the editing. Now, if I go in with the identify tool, all of this has been updated. So what did I use? What did I use here? For the street address, I got this from the parcel data set. I got the ward by intersecting that polygon with the ward boundary that's within my database. I got the distance to the nearest road, which is 73.68 meters, because we have to know where this park is going to be located, how close it's going to be to a road. And we obviously want a certain buffer between the park itself and the road. I know the name of the closest road, and this is the area that I just created on the map. And also under this location tab, I have the UTM coordinates. So I produce the UTM coordinates in case anybody wants to know. And I have the lat long coordinates. But not only that, I've also included, just to show you, that we can produce the degrees, minutes, seconds in this format using a spatial function. Next, under safety and emergency information, I want to know how close is the nearest hospital and which one is it. So the nearest hospital now I know is the Windsor Regional Hospital, Metropolitan Campus, and the distance to the nearest hospital is just almost 1.5 kilometers, again, as the crow flies. I also want to create some geometry output, and this is where it gets kind of cool. So I have the KML right here, and you could copy and paste that and save it as a KML or do you want. And with the QGIS forms, you can actually display GeoJSON, the actual JSON tree, and you can collapse things and show the whole thing, and we can see that it's a polygon, type is name, and we have the CRS information here. I also create some metadata whenever I'm running any of these queries, and I have default values that created. That's another thing that I didn't show you, but I showed in my course. And we can actually create the date that this polygon was created. So we have the full timestamp, it was created by which user, the date that it was modified, and it was modified by somebody. So when we first create it, it's created, those values are the same, but obviously if I updated this date modified and modified by, if it was done by another user, which would change. So it's nice little metadata that we collect about. We can sort of track who's changed, but you can do a lot with these trigger functions. You can actually create audit tables too, and any change that happens on one table can actually be written to another table, both the before and the after values. So it's really a powerful thing. It's one of the main reasons why we use databases is to automate this stuff. And this is really nice because this means that no longer would I have to create this polygon. Could you imagine doing this, all the work that I just did if we were doing it with like shape files? I would create a polygon, and then I would intersect it with the ward, or I would look at it visually and I would type ward 5. And then I would try to find the nearest street, and I would do some complex nearest neighbor analysis to find it, and I would get the value. And then I would load that and copy that onto the shapefile. My goodness, I'm tired. And I'm just on the third step here. I haven't even produced the coordinates or any of this. So a couple of lines of code and the computer is working for you. And then you have the advantage, right? Is that you do all this work really quickly, and then you just tell your boss, whew, it's a lot of work. It's going to take time. So this is the end of my picture show. I hope you enjoyed it. I hope it at least made Spatial SQL seem a little bit unscary. If you want to learn more, we are going to be doing an introduction to PostGIS this month. It's database month at Luna Geospatial. So we're doing PostGIS now, we're doing GeoPackage in 2 weeks. So we're going to be doing another free webinar just to introduce you on what you can do, introduce you to GeoPackage if you're not familiar with it and what you can do with it. And it's really awesome if you're going to save something in a file format. I say GeoPackage is the way to go for most things. But this training course is going to be on the 29th. We also do a follow-up a week later. So you sort of have a week to mess around with it. I create a database for you for this. So everybody who signs up gets their own little piece of a database, and they can mess around with it and play with it for a week and ask me questions. And then we have a follow-up Q&A, and we go through any burning questions that the participants have experienced. We have a bunch of people signed up for this already, so jump in. If it gets really popular, I'll create another session. I have had some people in Australia sign up, so if more people from Australia sign up, I will actually book a time for our friends in Australasia, at a time that works a little bit better for you, so you don't have to stay on till 3 in the morning. Advanced QGIS 1 is also going to be on May 27th. So if you took the intro to QGIS, or if you just want to do a few more advanced, learn a little bit more advanced functions within QGIS, that's going to be available too. Newsletter, if you're not signed up for the newsletter, this is where you find out about courses and all of this fun stuff that we do. And upcoming webinars, I'll be throwing a few up there. May is mobile data collection month. So we're going to be doing a little bit on QField. And we also have some people that are going to be joining us from Lutra Consulting to talk about merging and input. So watch for that. And we're going to be doing a whole seminar with them on that. So now I will take questions. I'm going to open up the chat. Ooh, look, I see chats. All right, let me go through. I have to read them. Listen, awesome. A lot of nice comments. Thanks, everyone. I'm really grateful that you made the time to spend with me here today. And I will mention, I don't know if I mentioned this first. I'm trying to see if there's any questions. This is great. Thanks, everyone. This will be on YouTube shortly, and we always email all participants. Will get an email eventually. I don't spam. I feel strongly against that. But I will send you something through MailChimp, and it will land in your mailbox. And I hope it doesn't end up in a spam folder, but it will be a link to the YouTube video, so you can check it out. I hope everybody had fun. And if there's no questions, I don't see any popping up right now. If I've missed any of these questions, I apologize. Please just email me. Send me an email at cpatterson@lunageo.com. Message me directly on Twitter at cliffpat. And I'd be happy to answer them. So, do you have a new one? Oh, can we find the trigger function? Very good question, Thomas. I will post all of the SQL that I showed you. I'll either give you a download link, or I'll just put it on my GitHub or something like that, and you can just download it from there. I'll probably put it on GitHub so it's on a more central place, because I'll probably update it over time also. But yeah, I will put all those functions up there, and you'll be able to have access to it. Would you advise to use the public? Oh, yeah, that's a really good question, John. I like using my own schemas. I rarely put anything in the public schema, mostly because there's a lot of magic that happens in the public schema. Things like when you're saving QGIS, projects to the database, when you're saving default styles to the database, it actually saves within a table within the public schema. A lot of functions are within the public schema. So I kind of like leaving that just for business. And I'll put data within individual schemas. So when I'm setting this up for a client, so let's say we're setting this up for, I don't know, an environmental organization. We might want to put a bunch of different boundary files, which is in a schema called boundaries. I treat them like file folders. So I'll put all of the upper tier, lower tier municipal boundaries. And if there's some KBA boundaries that you want to put within a certain folder, I'll put them in there. If you have parcel data sets, maybe I'll put that in a planning folder, and you have a bunch of other things. I really do like organizing my databases in that way so that anybody who comes in will be able to find something. Do you prefer to use tables or materialized views with triggers? Good question, Cedric. I will use, it's tricky. I like triggers more with tables. Materialized views are kind of tricky. That's something I'll go through a little bit in the course on views and materialized views. I've had trouble I rarely use views. They're very slow. With any large table, if you're loading it again, because it's just like it's running that query over and over again as you move around on the table. So I will use that. So yeah, materialized views, honestly, if it's a complex query like this, for what I just showed you for editing, that I would do it on a table. You can't really do that with a materialized view. You're not going to be editing and running these things. I would do the trigger on the table itself. But if you're going to have a bunch of different data sets that you want to run, then you can, like if you're going to run a complex query on a bunch of existing data sets and those data sets are changing, then that's where a materialized view comes in, because then you can just update the materialized view automatically. Good question. I'm not quite sure, but I am at the end of time and I do have to get off because I have to actually check out of this hotel. Send me follow-up questions. Thomas, I will address that question. I will send you an email on that, but I do have to log off at this point. But thank you everybody for your time. I do appreciate it. And we shall see you again at the next webinar. Thanks a lot, everyone.